Hi, welcome back to this YouTube channel. In today's video, we're going to look at how to use chain rule to find partial derivatives of functions. Now, when do we know when to use chain rule for a problem? So when you look at this function, the function z is a function of x and y, but the problem is asking us to find del z del s, which is not directly related to s. Now, one way you can solve this problem is to first of all substitute x in terms of s and t, and y in terms of s and t, and then find the partial derivative and find the partial derivatives directly from that. Okay, so there are two ways to do this. The first way is substitute what x is, which is, and substitute what y is, which is this, and then from there you can find this. And I think most of you would want to see both ways, so we can look at it both ways. Now, the second method is to work with what you have directly. So to find this del z del s using chain rule, because notice that what, okay, so let me write it here. Notice that z is a function of what, x and y, and x is a function of s and t, while y is also a function of what, x, s and t. So now in order to get to s, you need to pass through x and y. So this is how we write the chain rule regarding the partial derivatives. So first of all, we'll go through x, then the x, the s, plus we go through y times the y, the x, the s, right? So these are the two ways to solve the problem, right? Now, it's possible that when you solve it using the second method, you can have x as part of it, y as part of it. That is quite fine as well, okay? Unless it is, and unless you are told to leave your final answer in terms of s and t, you don't have to simplify those. Now, let's use the second method first, and we'll go back to the first method, right? Because I think most people are curious on how to find the second, to solve the second method. The first is quite direct. Most of you can solve this. Now, using the second method, first of all, we need to find del z del x. Now, from the function, z is given as what? X over y, right? So we know that what z is what, x over y. So derivative of this with respect to x is just basically 1 over y, right? As you can see, y is taken as a constant. Just think as if you're having 2x. Derivative of this is 2, or think about it as if you're having x over 5. Derivative of this is just 1 over 5, right? So it's just the same way. Derivative of this is just 1 over y. Now let's look for dx, um, the del x del s. So we know that what, function of x is s e raised to power t. So we know that what, x is s e raised to power t. Now to find the derivative of this with respect to s, it's also very clear that what, e raised to power t is just acting like a constant. So the answer will just be e raised to power t. Okay. Now let's move to the other one. Okay, let's move to the other one, which is del z del y. Now, what is del z del y? We can basically see, so we can look at y. Y is what? 1 plus s. So let's write it, y equal to 1 plus s e raised to power minus t. Okay. Now, del z, sorry, z is giving us what, x over y. So derivative of this, now we have to be careful how we solve this particular one, right? So we know that what, our z is x over y, and this can be written as what, y raised to power minus 1. Now this is just the derivative of a polynomial with negative power. So what would this give us? Del z del y will now be minus x y raised to power minus 2, right? So we bring the minus times what is here, then we reduce the power by 1, which is this, okay, which is minus x over y squared. Perfect. And finally, we have dy ds, right? So del y del s is just derivative of this with respect to s. You can see the derivative of the constant one is 0. Now derivative of this one is just going to give us e raised to power minus t. And we are done. So all we need to do now is to now substitute these values into this function, right? Let's not mix them up. Okay, now let's just substitute that. Del z del x is giving us 1 over y. So this is 1 over y times e raised to power t. This is dx ds plus del z del y, which is minus x over y squared multiplied by, so let's put bracket around, multiplied by this, multiplied by del y del s e raised to power minus t. So we can quickly write this e raised to power t over y, then minus x e raised to power minus t over y squared. So this is what I mean, that you can leave your answer in terms of what x and y. Okay. Now at this juncture, if you like, you can try to simplify further as much as you want, but this is quite fine. Okay. But if you would like to do that, you can just substitute what y is, what x is. So you can, if you want to move further, you can just say this is this over so take the LCM first. So you have y squared. So you have y e raised to power minus t minus x e raised to power minus t. So you can first of all, so let me just write it clearly. So you can first of all take the simplify this by taking the LCM and simplifying the terms. And from here, you can put what y is. Y is times e raised to power t minus what is x times e raised to power minus t all over 1 plus s e raised to power minus t. So you can quite do this. And if you open the bracket, you would have e raised to power minus t times e raised to power t. That is just 1. That will be e raised to power 0, and that will give us 1. So we just have this multiplied by e raised to power t. This term s e raised to power minus t times e raised to power t is just s. And in the other side too, this will also be minus s all over 1 plus s e raised to power minus t. Don't forget the square. And this will just give us e raised to power t over 1 plus s e raised to power minus t squared, right? So if you simplify in terms of s and t, this should be your final answer. If you like, you can do it this way. But I think this first one is also okay in terms of x, y, t, s, whatever you have. Okay. Now, what's the other thing? Okay, so we are done with respect to s now, and now let's move to with respect to t. So let's move to this side. Now we're going to look at del z del t. Okay, so it's the same process. It's going to be del z del x times the x dt plus del z del y times del y del t. It's just the same process that we just followed. So let me, okay. So now what is del z del t? I think, don't forget, del z del x is always, so this is the same 1 over y. What we need to find is del z del t, right? Now, don't forget that what your x is given here is s e raised to power t. So x is s e raised to power t. Now del x del t will now be differentiation of this, which is still the same function. Remember, although s is a constant, differentiation of e raised to power t is still going to be e raised to power t. Okay, that one is still the same. All right. Now, what else do we need? We need del z del y, which is the same thing as we had before, minus x over y squared. And finally, del y del t, which is derivative of this with respect to t. Now, don't forget your y is 1 plus s e raised to power minus t. Now, derivative of 1 is 0. Now, derivative of this one with respect to t would be minus s e raised to power minus t. How did I get this? S is constant, so we have it here. Derivative of e raised to power t is going to still be the same thing as e raised to power t multiplied by derivative of the inside of minus t, which is minus 1. That is how I got minus s e raised to power minus t. Now we can put things together, which is just del z del x, which is 1 over y times dx dt s e raised to power t plus del z del x del z del y, which is minus x over y square times del y del t, which is minus s e raised to power minus t. So putting this thing together, you have over y plus x s e raised to power minus t over y squared. Now, those I mean that this is also fine, but you can try to simplify further by taking the LCM, and you would have for t plus xs e raised to power minus t, and you can substitute what y is, what x is in this, and find your final answer. Okay, so you can do all of that, and that is still, and that will be fine. Okay. Now, this is the second method I will just for using chain rule, and so you can solve this problem that we're using chain rule. Now, let's move to the first method. Where is it? So let's come back here. We said we could directly substitute the values of x in terms of s and t, which is what we have here over this. Now, and then we can find directly. Now we can find dz del z del s. Right? Now, how do we do that? How do we do that? Now, notice that what this is a quotient rule, right? So we can think of this as the numerator as s e raised to power t, and the denominator as what? 1 plus s e raised to power minus t. Okay, so we need to find the derivative of the numerator with respect to x and of the denominator with respect to s, right? So du ds would be e raised to power t here, and also dv ds would be given as what? E raised to power minus t. I think we have done this before. Okay, now that we have this, so let me quickly delete this left hand side so that we can use this space for our work. Now, what do we use? We use quotient rule, which says that what? dz del z del s del s would be v du minus u dv all over v squared. Now this is du ds, this is dv ds, right? Now let's write that. What is v? V is giving us what? 1 plus s. So let me write it here. 1 plus s e raised to power minus t. Du, we got du, which is e raised to power minus t, minus u, what is u? S e raised to power t, times dv, what is dv? E raised to power minus t, all over v squared, which is 1 plus s e raised to power minus t squared. Now, when you check, it's the same computation that we had before. 1 times this is just e raised to power minus t. This times this is just s, minus this times this is just s again, all over 1 plus s e raised to power minus t squared. And this will just give you e raised to power minus t all over 1 plus s e raised to power minus t squared. You can see this answer is just exactly the same thing as we got here, right? So we can link both of them together. They are the same thing, right? It's the same computation. But wait, I'm having e raised to power minus t. Oh, I think there is a mistake here. The ds is just e raised to power t, not minus, right? So this should give us e raised to power t. Yeah, the rest is correct, right? So this is e raised to power t. Okay, good. So they are the same thing, as you can see. So this is how you can use the two different methods to solve the problem. Okay. Now your assignment is to your exercise here is to solve the same thing for dz del z del t, right? So you can use the same function. So you have your z as what do we just get? S e raised to power t all over 1 plus s e raised to power minus t. Now find del z del t, right? So this is your using this first method. So using quotient rule, can you solve this? So this will be assignment. And once you do it, make sure you go back to this particular expression for del z del t. Put substitute x here, substitute y here, and simplify and compare if those two answers are the same. So that will be your assignment for this particular problem. So hope I can get your answers in the comment section. Make sure once you've done it, just post it in the comment section. Let me take a look and see if that is correct. So have a nice day, and then see you guys in the next video.